Hello everyone, welcome back to another new video. Today in this video we are going to study about the gravitation. Okay, so our topic is gravitation. In detail we're gonna solve some most important numerical related to universal law of gravitation. Universal law of gravitation. Okay, so in very first we have to understand what is gravitation. Okay, so gravitation, very first write down the definition of gravitation. Okay, so gravitation means the force of attraction between any two bodies is called gravitation. Or you can simply call gravity. Okay, the gravitational force and this gravity both are the same thing. So gravity is also known as gravitational force, or you can say gravity simply. Okay, so it is denoted by capital F. Gravitational force is denoted by F. So write down here gravitational force, that is F. Or you can say gravitational force is denoted by F. Okay, so basically the Newton's gives the universal law of gravitation. Okay, so if there is a two bodies, suppose this is m1 and this is m2, having different mass m1 and m2, the distance between center to center, from center to center, suppose this is d. Okay, so two bodies are distance d, having mass m1 and m2. Then let's see what will be the universal law of gravitation. So now our topic is universal law of gravitation. Universal law of gravitation. So basically Newton gives two different universal law of gravitation. Okay, so in very first number, the gravitation between two bodies is directly proportional to the product of their masses. So if you analyze this figure, then the Newton's first law gives the gravitational force, that is F is directly proportional to the product of their masses. Their masses means this m1 and m2. F is directly proportional to m1 and m2. Okay, so this is our universal gravitational first law. Now let's move on to second law. But F is directly proportional to m1 and m2, but we have a condition, that is d equal to constant. Distance must be constant. So in second condition, second law, the gravitation between two bodies is inversely proportional to the distance between their center. So distance between these two masses is d. So it means gravitation, or simply you can say gravitational force, F is directly proportional to inversely proportional. So inversely means 1 by 2 the distance between their center, square of distance between the center. It means F is directly proportional to 1 by d square. Okay, so this is our second formula, and writing F is inversely proportional to 1 by d square, the mass m1 and m2 must be constant. So you can write here m1 and m2 constant. Okay, so these are the two equations. Now combining equation 1 and 2, combining equation 1 and 2, we get F is directly proportional m1 into m2 into d1 1 upon d square. So its value becomes upon d square. And as we know, if this directly proportional sign is removed, then certain constant we have to keep. So let's g is a constant, and if this directly proportional sign is removed, then we have to put any constant. So suppose this constant is g m1 m2 upon d square. Okay, hence we get the required expression. So this is the equation 3 is the required expression of the gravitational force, or you can say universal law of gravitation. Universal law of gravitation, or you can say the gravitational force, or simply gravity between these two bodies. Okay, so this law is given by the Newton. Now we have this basic formula, F equal to g m1 into m2 by d square. With the help of this formula, we have to calculate the gravitational force between two bodies. Either bodies may be small objects, or maybe like a huge masses like Mars, Moon, Sun, Earth. Okay, like this. So let's do some numerical regarding this. So most important and most BBI numerical. Okay. So in very first number we have most important numerical. This question is repeatedly asked in final examination SE. Okay, and this question is one of the most conceptual basic question. It gives you and it clears your all concept related to this gravitational force. So we have a big important question, and this question are repeatedly asked in our final examination. So two bodies with their mass with the mass of 200 kg each are kept 2 meters apart from their center on surface of Earth. Okay, and we have to calculate the force of attraction. Force of attraction produced between them. Okay, so now let's move to the solution. As I already told you, see here, two bodies with a mass 200 kg. We have given two bodies. Suppose this is one and this is two second body. two bodies with a mass of 200 kg. Both bodies have a same mass, that is 200 kg and 200 kg. Okay, so given mass of first body, that is m1 equal to 200 kg. Similarly, mass of second body, that is m2 equal to also same mass, so 200 kg, are kept 2 meter apart from their center. If this is center, this is center, these two are separated by distance, how much? 2 meter, 2 meter distance. So distance from where? From center to center, center to center, it is denoted by capital D, equal to how much? 2 meter. Okay, so we have to calculate the force of attraction. See here, if we in the question ask calculate the force of attraction, this force of attraction, calculate gravitational force, calculate force, calculate gravity. Okay, so both are the same things, keep in mind. So here, see here, we have to calculate the force of attraction. So we know the force of attraction, that in F equal to gm1 m2 upon d square. So the value of g is constant, that is 6.67 into 10 minus 11. The mass of m1 equal to 200 kg, m2 equal to 200 kg upon the value of d equal to 2. So here is a d square, it means 2 square. So after calculating these all value, you can calculate the final value of this. So if you calculate this in your calculator, then it value becomes 6.67 into 10 to the power minus 7 Newton. Okay, so this is our required force of attraction between these two bodies having mass 200 kg both and separated by a center to center distance 2 meter, which is required force. I hope you can understand. Now let's move on the next question. Question number 2. This is also one of the most important question. Such type of question is repeatedly asking in our SE examination. So what will be the force of attraction? What will be the force of attraction? What will be the force of attraction in extraction having masses 200 kg if the distance between them is half of the 2 meter. Okay, so let's start the solution. So solution given. So we have given what will be the force of attraction having a mass is 200 kg. So now I just write only symbolic, m1 equal to 200 kg. See, look here, there is a masses given, so it means m1 is also 200 kg, m2 is also 200 kg. And if the distance between them is half of the 2 meter, so the distance equal to what? Half of 2 meter means 2 by 2 meter equal to 1 meter. Now we have to calculate the force of attraction. So we know the force of attraction F equal to gm1 m2 upon d square. So the value of g is 6.67 into 10 to the power minus 11. The value of m1 equal to 200, m2 is also 200 upon d square. The value of d is 1, so 1 square. So if you calculate this value in your calculator, then it value becomes 26.68 into 10 to the power minus 6 Newton. So you can write here in conclusion, hence the force of attraction attraction between two bodies is how much? 26.68 Newton divided minus 6 Newton, which is our required force of attraction. Okay, now let's move on the third question. So in third number we have question over here. What will be the, this is also one of the most important question, and this is repeatedly asked in a final examination. What will be the force produced between the bodies if mass of one body is 200 kg and another body is tripled. Okay, having distance between them is constant. Okay, so now solution. See here, we have to first from any given question we have to write the value of m1, m2 and d. So what will be the force of attraction between the, if masses of one body is 200? So m1 is given over here 200 kg, and another body is triple. Triple means 3 times m1. See here, triple, so triple than first one, so it means 3 into 200, it means 600 kg. Okay, having distance between them is constant. So distance between them is constant is given in the question 2 meter. Okay, so distance equal to how much? 2 meter. So we have to calculate the force produced between two bodies. So F equal to, we know, d square. The value of g is 6.67 10 to the power minus 11. The value of m1 equal to 200, m2 equal to 600 upon d square means 2 square. So if you calculate, this value becomes 2.001 into 10 to the minus 6 Newton. Hence the force of attraction between two bodies will be this 2.001 into 10 to the minus 6 Newton. Okay, so these are the so easy you can calculate. Now let's move on to the next question. This is also important, most important question. Okay, so this is most BBI question. This type of question is asked in SE so many times. Okay, so the mass of Earth is 6 into 10 to the power minus 24 kg, and the mass of Jupiter is 319 times more than the Earth. And the distance from center to center of Earth and Jupiter is 9.68 into 10 to the minus 11 meter. Then we have to calculate the force of attraction between Earth and Jupiter. Okay, so this is one of the most important question, and this such type of question is repeatedly asked in your final examination. So this is so easy. The mass of earth, see, the mass of earth means the value of m1 is given 6 Newton to 24 kg. The mass of Jupiter, that is m2, is 319 times. It means 319 into this mass of m1. So 319 into 6 into 10 to the power 24. Okay. And the center to center distance of Earth and Jupiter is 9.68 into 10 to the power 11 meter. So if the distance is given in kilometer, then you have to convert this kilometer into meter, because kg and meter is a SI unit. So if there is in different unit, then you have to, very first you have to convert into SI unit, that is mass SI unit is kg and distance is unit is meter. Then only you have to apply the force formula. Okay, otherwise your answer will be mistake. So we know the force of attraction F equal to G m1 m2 upon d square. So the value of G is 6.67 into 10 to the power minus 11 into the value of m1 equal to 6 into 10 to the power 24 into the value of m2 equal to 319 into 6 to 10 to the power 24 upon d square. D means 9.68 whole square. So I strongly suggest you that you have to keep this all these value directly in your calculator. Don't try to do individually. First multiply this, not, this is not required. You can directly click on the calculator these all these values and you directly get the answer. Okay, so the finally you get the value 8.17 into 10 to the power 70 Newton if you calculate in the calculator. So I strongly suggest you all, please try to solve with the help of calculator directly. Okay, it will save your time and there is no risk to mistake your answer. Okay, hence the force of attraction between the sun, between the earth and Jupiter is 8.17 into 10 to the power 70 Newton, which is our required force of attraction. Okay, so this is our question number 4. Now let's do one next question. That is question number 5. This is also one of the most repeated question. So in question number 5, this is also important, most important question. An apple with mass of 200 gram falls from a tree. What is acceleration of apple towards the earth? We have to calculate the acceleration, and we have also what is acceleration of earth towards the apple. We have to also calculate this one. And next one is this one. What is the acceleration of apple towards the earth and what is the acceleration of earth towards the apple? So see here we have two bodies. Suppose this is earth and this is apple. Okay, so due to this having the force of attraction between these two bodies, because these two are separated with certain distance. Okay, and let's see what is the acceleration of apple towards the earth. Towards earth means this acceleration of E, and the acceleration of the earth towards the apple. So this is denoted by E, towards apple denoted by A, towards earth denoted by E. Okay, so now let's see solution. So in very first we have given mass of apple, that is a small m is given over here, 200 gram. 200 gram means 0.2 kg. If we divide by 1000, then its value becomes 0.2 kg. And mass of earth, that is capital M, is given over 6 Newton to the power 24 kg. Okay, and as we know, the radius of earth, if in the question is given, then you can take the value. If not given, then you have to remember the value of this, r equal to 6.4 into 10 to the power 6 meter. Okay, so the radius of earth is 6.4 into 10 to the power 6 meter. You have to keep in mind. If sometimes in the question is not given, then you have to write yourself. Okay, and you have to also know the value of G, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so as we know, the force of attraction between the earth and this apple, this is earth and apple, is Fg m1 into m2 by d square, but here is m, so we can keep m or m upon d square. Okay, but in this case, this apple, see here, if this is earth and the apple is nearly on the surface of this earth, okay, apple tree, so you can directly take center to center distance is, see here, this is r. Okay, so you can also write